Hey everyone, and welcome to Data Science, Deep Learning in Python. In this lecture, we'll be discussing what this course is about, and I'll give you the 10,000-foot view of how this course is structured. This course is an in-depth look at deep learning fundamentals. So what do I mean by in-depth? Many people actually confuse the word depth with breadth, but in fact, these are opposite words. Breadth means you learn a lot of different topics, but you only scratch the surface. Depth means you drill down on one specific topic and you look at all the details pertaining to that one topic. It goes far beyond the surface level. So why should we go in depth? Well, the reason for this is, many students often say, I took this course on deep learning. We built CNNs, RNNs, LSTMs, GANs, and so on, but I don't really understand how it all works. I can copy code the instructor gave me, but I can't create something new. The instructor only gave me high-level intuitions, but if I try to read any deep learning papers, I just don't understand the math. And well, this is very unfortunate because those deep learning papers are where all the new interesting knowledge can be found. It's certainly very attractive to think that deep learning can be done with just a few lines of Keras. But it's almost like an illusion. If your boss comes to you one day and says, "Hey employee, can you implement this paper?" Your answer cannot be no, because they didn't teach that in my Keras class. Well, I think both you and I can agree, and probably your boss too, that this is not acceptable. Luckily, this is a really easy problem to fix. The answer is to simply begin by taking your first steps to understanding the theory behind deep learning. No more copying Keras code from other people. This course is all about true understanding. In the rest of this lecture, I want to give you an outline for this course and describe to you what you should expect to learn. The great majority of this course is on a technique called backpropagation. This is the backbone of deep learning. All of deep learning, from the 1980s to the state of the art today, depends on this technique. This course has what I hope is a fairly straightforward outline. There are 4 major sections of this course, broken down into a logical sequence. The first major section is focused on making predictions with the neural network and the architecture of a neural network. This will answer the question, what is a neural network in the first place? This is all about how to do the basic computations in a neural network to get from the input to the output. The second major section of this course is focused on training neural networks. This will answer the question, how does a neural network learn? This is the reason why we're here. We want to be able to build intelligent machines that have learning capacity. The third major section of this course is focused on practical issues surrounding neural networks. What kinds of problems can neural networks solve, and can we visualize these? How do we ensure that neural networks can generalize well to unseen data, which is the data that we actually care about? The fourth major section of this course is focused on a project where you will get to practice building a neural network using classes and objects. We'll also take this opportunity to work on a very real-world dataset. This is important because this is generally how we build things in practice. We want our code to be reusable. This is the principle behind libraries like scikit-learn, TensorFlow, and PyTorch. You don't want to rewrite a neural network again and again. You want to be able to write it once and use it everywhere. So who should take this course? This course is designed for students who already have a solid background in linear models for regression and classification. This means that you know about standard techniques such as loss functions and gradient descent. You can derive these methods on paper from scratch. You know how to code these things yourself in Python. Now, a lot of people hear these prerequisites and think of them as obstacles, but this is untrue. They are more like stepping stones. They exist to help you on your journey. Believe me, your life will be a lot harder if you try to learn everything all at once, instead of taking things step by step, as recommended. The reason you are taking this course is because you're now ready to extend your knowledge to more complex models, such as neural networks. You should understand that this course is not the end of your journey, but rather just the beginning. After you learn about the fundamentals of neural networks in this course, you'll be ready to truly understand and appreciate many of the modern enhancements and developments that we've made in deep learning. These include techniques such as atom, dropout, and batch normalization. These include new architectures such as CNNs and RNNs. Guys, this course is the missing link that so many students are looking for when it comes to deep learning. I've seen a lot of students try to get into deep learning. They usually start with Keras because it looks so easy. But eventually, things get so complex, they stop and wonder, do I really understand what I am doing? Or am I just copying Keras code I've seen before? What happens when it's time to create something new? What happens when your boss says, hey, implement this paper, and it's just a bunch of math equations that you can't understand? What happens when it's time to create something that no one else has ever built before? Well, why can't you be the first person to build it? I hope that you are here because you want to be the kind of engineer that really understands how things work and to create your own things. You want to build new things, not just repeat things you've seen someone else do. That is the kind of student that this course is for. I hope you agree that this is a worthwhile journey. Thanks for listening, and I'll see you in the next lecture. So in this lecture, we're going to discuss where to get the code for this course. The code for this course can be downloaded from my GitHub page, github.com/lazyprogrammer/machine learning examples. So this is a repository for all my courses. Now, generally speaking, there is one folder per course, although there are some exceptions. For instance, some secondary folders, which don't contain the main code in this course, are used for multiple courses. So multiple courses may use the files in this secondary folder. At the same time, it should be very easy to figure out, since the code you'll see in the lecture videos will reference any relevant folders. So you'll literally see the file path in the code, which will clear up any potential ambiguities. In any case, to get to the main folder for this course, simply click on the resources link attached to this lecture. Now, if you've never used GitHub before, then there are several ways for you to download the course repository. There are also several ways you should not download the repository. So first, let's start with some options for what you should do. Option number 1 is to use the git clone command. You can enter this in the console, as you can see here. Option number 2 is, if you are not comfortable using the console, then you can simply use the download button. Although I would still prefer option number 1. Now, one thing to keep in mind is that the internet is a constantly changing place. So do not freak out if GitHub has a new design by the time you visit this page. I am confident in your ability to figure this out. And the reason I mention this is because I had one student in the past who looked at this lecture and, saw that the buttons were a different color or a different shape or something. And then all of a sudden he didn't know what to do and couldn't follow the lecture. But really, it's not that hard. All you need to do is use your pattern recognition abilities. So consider this your first exercise for the course. By the end of this lecture, you should have the entire course repository downloaded to your local machine using either of the two methods above. Now, please note that if you're new to Git or GitHub and you find yourself a bit intimidated, please do not be. You do not have to know how to use Git for either of the previous two methods. Now, here are some things you should not do that I've seen several students do in the past. Number 1, do not try to download each file one by one. As mentioned previously, this is not the way to use Git. Number 2, on a similar note, do not go to File and Save As. This is not how to download files from GitHub. Doing this will download the web page to view the file, not the file itself. So if you look at the file and you see a bunch of HTML, you know that you did it wrong because there's no HTML in this course repo. In fact, number 1 and number 2 are very silly because they actually take a lot more effort than simply using either of the methods I mentioned earlier. So it's actually more difficult to do this the wrong way than to do it the right way. And number 3, if you want to fork my repository, please feel free to do so, but try your best to keep it up to date. I make updates constantly, so make sure you pull these updates. And if you don't think you'll be able to do so, then simply use the git clone command instead. And on that note, when you do download my repository, make sure it's actually my URL and not someone else's fork. And number 4. So this might sound silly, but your fellow students have proven to me that this needs to be said. There is no need to type anything character by character. Simply use the copy button. So if you come back here and you say, I can't type all these characters, it's too complicated, I'm going to refer you back to this lecture. So one extra note about the GitHub repo. Most courses also contain a file called extrareading.txt. This file contains reference material for the course, like journal articles, books, and so forth. So if you hear me referring to extrareading.txt in the lectures, this is where it can be found. Reading these materials is optional, but they are there in case you want to further your studies. Okay, so I want to mention a couple points pertaining to the code in this course. Firstly, some of you, especially those who don't necessarily meet the prerequisites, may be asking, what is Git and how do I use it? The short answer is, Git is a way for developers to manage and track changes in their code. You might be used to writing code by yourself, but when you're working with a team of 2 or 10 or even 10,000 people, you need a system to keep things in order. So this is why, for example, Git is superior to uploading code files to this website. And learning how to use Git is very simple. There are many tutorials out there that will work just fine. For this course, you only need one command, which is the one I showed you before. So you don't even need to understand Git, you just need to copy and paste the command I gave you. And therefore, I don't suspect this will be an issue unless you also don't know how to run commands. But if that is the case, then as mentioned, you can simply click the button that says download. At this point, I'll assume you need no further assistance. And just as a side note, although you don't need to know how to use Git for this course, it is a valuable skill that will be necessary if you plan to work for any company where your job is to write code. I don't know any companies that write software that do not use some kind of version control like Git. So if you do want to have a job in this field, it's something you're going to have to learn about sooner or later. Now, another common question I see from beginners is, should you code along? The short answer is no. Now, you may have taken online courses in the past that encouraged you to code along, but the reality is this is going to give you a very false impression of how code is actually written. Coding is not a monkey see, monkey do type of thing. If you're learning to play guitar or do some yoga moves, then yes, that makes sense. But coding involves lots of thinking, not just typing. If you think you're going to write a complex algorithm in 20 minutes without actually paying attention to design or structure, and without debugging and going back to fix things, think again. Real code in the real world is not written linearly from start to end. If you've gotten this false impression from other courses, now is the time to improve your approach. I encourage you to watch the lecture, Should You Code Along, for a more detailed discussion. This brings us to our next point, which is, what are the exercises for this course? Now, in some cases, this will be obvious, because I'm going to say, here is an exercise, please do it. But sometimes it's going to be less obvious, and I'm going to trust that you've watched this lecture and understood what I'm saying. Basically, any time that you see code, that is an exercise. There are 2 types of code you might see. Number 1, I've just taught you an algorithm, in which case the next code lecture will involve an implementation of that algorithm. And number 2, I'm going to walk you through how to use a library or an API. For example, TensorFlow or PyTorch or stats models. So what is your exercise? Well, for case number 1, your exercise is to implement that algorithm yourself before you ever see my code. My code is actually the solution to that exercise. So don't take what I call the couch potato approach, where you just sit there watching each lecture one by one without doing any coding. That is not the intent of this course. And if you're looking at the solution to the exercise before you do the exercise, this is basically cheating and copying your homework. Now, obviously, what you do is up to you, but I hope that you'll do the exercises as intended. Now, for case number 2, it's a little bit different. Obviously, you're not going to know the syntax for a library or an API before I even show it to you. In this case, you should go ahead and watch the full code lecture, which will show you the syntax and how things work. Replicating the code is very useful because you're building muscle memory. And although this sounds like it should be easy, it's not. In fact, making mistakes when trying to replicate the code is the number one mistake I see on the Q&A. And yes, you heard that correctly. Even after seeing all the code work perfectly right in front of their eyes, students still have trouble just copying that code without making mistakes. And for those of you not typing code at all, a lot of people mistakenly believe that just seeing the code is enough, but actually being able to type the code makes you much more capable of using it in the future. But the most important exercise comes after you've watched the lecture. You should be able to implement that same code yourself on another dataset you care about. I assume that you're taking this course because you have some dataset you want to analyze. And if not, there are plenty of resources out there where you can find free datasets, so please choose one that interests you. Note that by this measure, most of my courses have at least 10 to 30 exercises, so try to do as many as possible. And also note that many courses contain examples of both number 1 and number 2 types of exercises, and you should be able to recognize it when you see it. Okay, so hopefully the exercises for this course are clear, and if not, please make a question on the Q&A. Now, the next question I want to tackle is a funny one, because I honestly didn't think that this was a question I would need to answer. But here we are. So, some students really like Jupyter Notebook very much, while other students dislike it. Some students really like PyCharm. So you might ask, why am I not using whatever your favorite tool is? And the answer is, this question is totally irrelevant. Now, you might think I'm being dismissive of your concerns, but in fact, the reason people have this question is because they don't yet know how Python works. After this lecture, I hope you'll have a better understanding. So, in this course, I'm providing you with Python code. You'll get that Python code either in a Colab notebook or a Python file, but there's really no difference. Remember that in this course, this is a video course. You're just seeing code on a screen. What I use is irrelevant because you can't touch it nor interact with it. I may as well be using Microsoft Word or PowerPoint, and it would make no difference. What you do with that Python code is totally up to you. You can take my Python script and paste that into a Jupyter Notebook, or PyCharm, or open it up in Visual Studio Code. It's completely your choice. Python code works the same, no matter what environment it's in. The same code will work in a Python file, in Jupyter Notebook, in Colab Notebook, and so forth. And if you're having trouble understanding this, please use the Q&A so I can help you sort it out. So in this lecture, I want to give you a few quick tips in order to help you succeed in this course. Now, generally speaking, I find that when students follow these tips, they always succeed. And most often, when I see students that are not succeeding, it is because they are not following these tips. Now, I want to first mention that I truly believe that anyone can succeed in this course. This is the case whether you are a teenager still in high school, or a senior who's retired and it's been decades since you've studied college math. In all cases, it really comes down to following instructions. Being diligent is key. As long as you can make a promise to yourself to be diligent and follow these guidelines, then I can promise you that you will succeed. Now that being said, what are the tips? In brief, tip number 1 is to use the Q&A. Too often, I see comments from students saying, "Oh, XYZ is missing from this course." My response is typically, well, actually XYZ is covered in Lecture 5, you simply missed it. But you see, I can't tell you that if you don't ask. So what's the better outcome? you live your whole life never knowing the answer to this question, or you simply ask, maybe bruise your ego a little bit, but at the very least improve your knowledge and skill. I prefer the outcome that results in you being better and more knowledgeable. Now, sometimes students reject this tip and say, but I didn't know what question to ask. This is good. You are exactly who should be asking questions. The reason you don't know how to formulate your question is because you haven't thought through the subject thoroughly enough. Most of the time, what I've seen is that, in the process of trying to come up with a question, the question often answers itself. Okay, so tip number 2 is to meet the prerequisites to this course. Now, a lot of students think of prerequisites as a barrier to entry. They think, oh, if the instructor mentions the prerequisites, he's punishing me by making me do more work, and he's saying I'm dumb for not knowing this stuff. Guys, this is not true. The prerequisites are simply information which exists to help you. It's information. It's not a barrier. It's not anything to attack you. It's simply information. So how does this information help you? Well, after you have this information, if you ever see anything in this course and you think, that looks weird, I've never seen this before, at that point, it's now a good time to revisit the prerequisites to make sure that there wasn't something you missed. If you didn't have the prerequisite list, then you would have no idea where to look. But with the prerequisite list, now you have a guide that tells you what you might be missing. Okay, so now on to tip number 3. This is something I've mentioned already, but it's so important that it's worth it to repeat. Be actively involved and get your hands dirty in this course. Like, if your hands are not physically moving while you are taking this course, you are not doing this correctly. There are 2 types of lectures in this course: conceptual lectures and coding lectures. With conceptual lectures, you need to be taking handwritten notes. What I've seen myself in the past, what I've seen many other people say, and what a lot of psychological research demonstrates, is that taking handwritten notes is a superior method of learning and absorbing information. This is better than staring at slides, better than watching videos passively, and better than even typing notes. Something about physically writing builds a superior mind-muscle connection. Now, when it comes to coding lectures, you already know this, but open up your favorite coding environment and write that code. If it's a course where you're learning an algorithm, then remember that implementing the algorithm is your exercise for the course. If you're just watching the lectures all the way through and twiddling your thumbs, then you are cheating by looking at the solution before completing the exercise yourself. But whether you're implementing an algorithm or just learning about a library, you must actually write code. I don't know any data scientists or machine learning engineers who don't code. Now, I just want to mention that this list is a condensed version of the full How to Succeed lecture, which can be found in the FAQ of this course. So if you have any objections to these tips or you think that they don't quite make sense, please check out that lecture for more detail. Okay, so what is the common thread between all these tips? The common thread is that the reason students don't follow these tips is because they let their egos get in the way. In fact, ego is the number one thing holding you back from succeeding in this course. Your pride is holding you back from succeeding in this course. Here's a fun fact. I've noticed a disproportionately large number of students claiming to have PhDs, but who do very poorly. Yet I see undergrads, masters, and even high school students who do better. How can this be? Well, you see, the problem with PhDs is that they think they are so smart that they have nothing left to learn. This is an example of ego and pride holding them back from learning new things. For tip number 1, ego holds people back from using the Q&A. Often, using the Q&A involves you asking a question which reveals your mistaken assumptions, which will then be corrected by whomever answers the question. This might hurt you a little bit, knowing that you got something wrong. But as mentioned, it's better to learn that you are wrong instead of continuing to be wrong and blissfully ignorant. For tip number 2, ego holds people back from meeting the prerequisites. They think, I took calculus, therefore I know calculus, and anything that involves calculus that I see in the future, I must understand, otherwise it wasn't explained correctly. Guys, this is not a good way to go through life. I learn new things about machine learning constantly, despite the fact that I took my first machine learning course over a decade ago. And let's be clear, if you got a B or a C in your course, which is a so-called average grade, that means quantitatively, your understanding was only at 60 or 70%. Now, another common excuse I see is, oh yeah, well I took calculus 20 years ago, so I forgot everything. It's now your responsibility to teach me everything again. Guys, no, this does not count as meeting the prerequisites. Remember that the prerequisites are there to ensure you have a skill that you can make use of. It is not a list of credentials. Credentials might matter when you apply for a job, but they're irrelevant in a self-paced course when all you have to depend on is yourself. Think of it this way. Would you fly an airplane if you had a piece of paper saying that you could, but in actuality, you forgot everything about how to actually fly airplanes? I think that would be very dangerous, and I don't think that any normal person would answer yes to this question. Finally, for tip number 3, ego holds people back from getting their hands dirty and taking notes and writing code. I can tell that this is the case because when I mention how writing code is a great exercise, and it is literally the job you will do as a data scientist, people would rather argue with me than accept this advice. They care more about calling me names and making threats than they do about actually becoming better data scientists. They simply cannot handle the reality that muscle memory exists. Coding is a useful exercise, and coding is literally the job description. They would rather believe in their minds that they can write perfect code without any practice. The reason they're afraid to code is that once they start, they might make mistakes, which would expose their imperfect coding abilities. And that's the most difficult thing for someone with too much pride and too much ego. They simply cannot face the idea of being wrong or making mistakes. It's too burdensome to bear. Okay, so I hope you guys are getting the idea. Do not let your ego get in the way of your success. Don't be afraid to be wrong, and follow these instructions as diligently as possible. Thanks for listening, and I'll see you in the next lecture.